Good morning friends, welcome back to Panika Tutorials. In the last video, I have discussed about the double linked list. In this video, I want to discuss how to create the nodes in the double linked list. So I request everyone to watch the complete video for better understanding. First, let me give an overview about the double linked list. Then I will discuss the C program to create the nodes in the double linked list. If you look at this double linked list, it is a collection of nodes and each node will have data, address of the previous node and address of the next node. Is it clear? So as it is a first node, address of the previous node will have null, and as it is a last node, address of the next node will be null. Is it clear? If you look at this node, address of the previous node is 100, so it is stored here. Address of the next node is 300, so it is stored here. And always we will have a pointer called head which is pointing to the first node. So it will carry the address of the first node. Is it clear? So this is about the double linked list. Now let me discuss how can we create the nodes in the double linked list. To do that one, first I need to define a structure. Okay, how can I define a structure? I have to write strut, name of the structure, so I will write it as node. Then I need to define the members. One is the address of the previous node of type strut node, so I will write it as previous, name of the pointer is previous, and data type is strut node because it is storing the address of a node. What is a pointer? Pointer is a variable which stores the address of another variable. If it is an integer pointer, it stores the address of an integer variable. Similarly, this is a pointer which stores the address of a strut node. So that's why you have to define the data type of the pointer as strut node. Is it clear? Then I want to store a data which is an integer, and then address of the next node I want to store. So I will write here as strut node of next. So I have defined a structure. If I have defined a structure, memory will not be allocated unless until I declare the variables of the structure. Now I need two pointers. Okay, one is the head, another one is tail. I will discuss what is the purpose of that one. So I will declare two pointers of strut node type. One is head, another one is tail. Okay, first I will initialize head and tail is equal to null. So they are null pointers right now. They are not pointing to any memory location. Is it clear? Now let me erase this one so that I can use this space to discuss the further concepts. Okay, now look at here. Initially head and tail having the null value. So this is having the null and head is also having the null value. Okay, now if head and tail is null, or you can say that if head is equal to null, you can say that double linked list is empty. So whatever the node you are creating, that is the first node. Okay, so let me write the user defined function to create the node. So void create. Okay, it is a user defined function and this function does not return any value, so that's why return type I mentioned as void. Now to do that one, first I need to declare a pointer. Okay, strut node new node. So this new node is a pointer. Now I need to allocate the memory dynamically for a node. Okay, so how can I do it? I will write new node is equal to, okay, strut node star. I am doing the typecasting. Okay, then I will use malloc function, and then I need to specify the size you want, size of strut node. Is it clear? Now you know what is the malloc function will do. The malloc function will allocate the memory or create the memory dynamically, meaning is that it will allocate the memory during the runtime. How much memory will be required, that you have to specify here. So I want to create a one node. So whatever the size, I am giving a size of operator and strut node. So how much memory is required, that much memory will be allocated during the runtime. And this malloc function will return a void pointer, but my pointer is a strut node, so that's why I'm doing a typecasting. So if memory has been successfully allocated, the base address of the allocated memory will be stored in the pointer called new node. Due to some issues, memory has not been successfully allocated, a malloc function will return a null value. Is it clear? Let's assume that memory has been successfully allocated and new node has been created. Once the new node has been created, let's take that like this, a node has been created in some address location 100. Let's take that. And you have a new node which is having the base address is 100. Is it clear? Are you able to understand? Now, what you need to do? You need to ask the user to enter the data. Okay? So, let me write the statement printf enter the value. Okay? Once the user has entered the value, you need to read it with the help of scanf function, scanf %d, because you are reading an integer, because you have specified the data type of the data as int. So format specifier you should use %d and then ampersand new node. As it is a pointer, you should access the member of a structure node with the help of arrow operator. Okay, data. Now whatever the user has entered the value, suppose let's take that user has entered the value 10, that will be stored here. Is it clear? Then you need to write new node of previous is equal to new node of next. Oh, I should write new node. New node of next is equal to null. So as it is a new node, you are entering the data and you are making these two pointers as a null pointers. Is it clear? Now how can you check this is the first node or till now the linked list is empty? So if you have a condition like if head is equal to null, then I can say that linked list is empty. Whatever the node I am creating, that is the first node. Okay, so if it is so, then what you need to do? You need to make head is equal to tail is equal to new node. Okay, what is the new node consists of? It consists of address called 100. So that you are assigning to the head and tail. Now head also consists of 100 memory location and tail also consists of memory location 100. So now head and tail both are pointing to the first node. Anything else we have to do? Address of the previous node. As it is the first node, address of the previous node will be null, and as it is a last node, address of the next node is still null. So this we have done. We have successfully created one node and inserted into the linked list. Is it clear? Anything else we need to do? No, nothing. Is it clear? Now what we need to do? We need to check if the linked list is not empty. If head is not equal to null, what I have to do? Okay. Else, then what should I do? So now let's take that again. I have created another node. Okay, using this strut node, new node is equal to this one. Again, user has called this create function. That time this condition was failed. Now it comes to the else block. So let's take that user has entered the value 20 and we have written new node of previous is equal to new node of next is equal to null. So now this is null and this is also null. Now I want to insert this node to this after this one. So this is the first node and this is the second node. So what I have to do? First thing I have to do is that always head will be pointing to the first node. Now tail should be pointing this one. Now before that one, what are the things we should do? Look at the things. First one is that Here this node, see, this is the first node. If this is the second node, what is the address of next node? Here it should come as 200. Am I right or wrong? So how can we write? We will write temp of next, because, oh sorry, not temp, we'll write tail. Okay, tail is pointing to 100 of next. Okay, tail of next is equal to, in which pointer this 200 will be there? As it is a new node, pointer is pointing this one, new node will have the value 200. Okay, let me write it as n, which is consists of 200. So tail of next is equal to new node. Now what is the value is there in the new node pointer? 200. So that 200 will come here. So we have successfully created one link from this node to this node. Is it clear? Are you able to understand it or not? Now this link we should create, because this is the node, address of the previous node, which is 100. Where it is having? It is having at the tail. So what I should do is that new node of previous is equal to tail. Okay, is it clear? Are you able to understand? So here we will get 100. Okay, so now we have created another link. Okay, so these two links have been created. Now tail should be pointing to the last node. This is the last node. Okay, initially the linked list is empty, so head and tail pointing to both the one. Now I want the head to be pointing to the first node in the linked list, tail to be pointed at the last. Okay, so that any new node I am inserting, so that it can be inserted with the help of the tail pointer. So what I should write? Tail is equal to, okay, tail of next. Okay, so let me write this one. So 200, and this will become 200. Okay, is it clear? Tail is equal to tail of next. So this will become 200. So this node is pointing to this node. Is it clear for you? Let me close the else. Let me discuss with another example. We have created the two nodes. Now I want to create the third node. The third node has been successfully created. Let's take that. Here you have successfully created the third node, and you have inserted the value 30 here, and this is null, this is null. Okay, now look at here. Head is equal to null? No, head is consists of address called 100, which is not equal to null. So this condition will be failed. So it will come to the else block. Look at what are the statements we have written. Tail of next is equal to new node. This node address is 300. So new node consists of value 300. So tail of next. Okay. So in place of this null, we are writing new node, which is 300. So we have created a one link from this node to this node. Okay, means forward link has been successfully created. New node of previous is equal to tail. New node is 300. 300 node of previous is this one, is equal to tail. What is the value is there in the tail? 200. So 200 will come here. So now we have created a backward link. Is it clear? Are you able to understand? Tail is equal to tail of next. What is tail of next is there? Tail is this one. Tail of next is 300. That you are assigning to tail. Now tail becomes 300. So it is pointing to this node. Okay. So maybe now you would have understood what is the purpose of maintaining another pointer called tail pointer, because whenever you are inserting any node or creating a new node, and if you want to append it, you can directly do with the help of this pointer called tail. You no need to traverse from the first node to the last node. Is it clear? So let me close the function. So this is the function will be useful for you to create the nodes in the linked list. Is it clear? Now let me discuss about how to display the elements. Okay. How to display the elements in a double linked list. We have successfully created the nodes. Now I want to display the elements in the linked list. So I will write a user defined function called display. So void display, I will create a temporary pointer, okay, strut node of temp. I will assign the value which is there in the head. So I am creating a one pointer called temp, and I am assigning what is the address is there in the head, so which is 100. So now even this temp is pointing to the first node in the double linked list. Then what I can write is that while temp not equal to null, okay, while temp not equal to null, you can write printf %d \n temp of data, okay, is it clear? Then you can write temp is equal to temp of next. Let me trace this program with the help of this example. Now initially temp is having the value 100, so it is pointing to this node. While temp not equal to null, what is temp is consists of 100. 100 is not equal to null. So this condition is true. If this condition is true, we need to execute these two statements which are there in the while loop. What is that one? Printf %d \n temp of data, 100 of data, so which is 10. 10 will be displayed and cursor will be pointing to the next line. Now temp is equal to temp of next. Temp of next is what? Temp is 100, of next is 200, that you are assigning here. So now temp is consists of address called 200, so which is pointing to the second node in the double linked list. Now again you will check the condition. What is the condition? Temp not equal to null. 200 is not equal to null, so the condition is true. If this condition is true, again you are printing temp of data. 200 of data is 20. So 20 will be displayed and cursor will be pointing to the next line because we have written \n character. Okay. Then temp is equal to temp of next. Temp of next is 300. So you will get here 300. Okay. So now this temp is pointing to this node. Now temp not equal to null. Yes, 300 not equal to null. The condition is true. If the condition is true, we will execute these two statements. What is the first statement? Printf %d temp of data. Temp is 300, 300 of data is 30. So the value 30 will be displayed and it will be pointing to the next one. Now temp is equal to temp of next. 300 next is null. So now we got the value called null in the temp pointer. Okay. Now look at here. What is the condition? Temp not equal to null, but null is not equal to null. Null is equal to null. So the condition is failed. If this condition is failed, it will come out from the while loop. Here, if you want to write, you can write another thing also. Before this, if you want to write one more statement, you can write it. Okay. What is that statement? I will discuss for you. Let me erase this one and I will discuss that one. I hope you have understood how to display the elements. Okay. Before that, you need to check this one. If head is equal to null, then you should display that linked list is empty. Printf list is empty. Okay, I hope it is clear for you. Else, if head is not equal to null, some nodes are there, then you should display the element. So while temp not equal to null, okay, then you will write printf %d \n temp of data. Then temp is equal to temp of next. Okay, close the while loop, close the else loop, close the function. See, this display function, what it is doing? It is displaying the elements from first node to the last node. If you want to display the elements in the reverse order, meaning is that you want to display the elements from the last node to the first node. Is it possible? Yes, it is possible. From this node, you can traverse to this node because you have the address of the previous node. From this node, you can traverse. So what you have to write is that if you want to display in the reverse order, you create a temp pointer and it should be initialized to tail. Okay, temp is equal to tail. Then here you will write again head is equal to null, or tail is equal to null. Here in place of head you can write here tail. If tail is equal to null, then list is empty. Else, while temp not equal to null, you will write this one, printf %d temp of data. Here in place of temp is equal to temp of next, what you have to write? Temp is equal to temp of previous, because from this node you have to go this node. How can you go? This is the previous one, it is there. So accordingly you can modify. Is it clear? If you want to display in the reverse order. So I hope you have understood how to create the nodes in the double linked list and how to display the data in the double linked list. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. In the next video, I will discuss how can we insert the elements or the nodes in the double linked list. I will discuss the three scenarios. One is that inserting at the beginning, at the end, after a particular position. So I request everyone to watch the next video. Thank you for watching the complete video. Have a nice day.